This video is sponsored by Thangs.com. Imported CAD geometry often proves to be challenging. Fortunately, Fusion 360 has a few workflows that can help. I'm going to import this Google Home Mini from GrabCAD, which I've linked below this video. There are two main ways to import a file into Fusion 360. First, we can go to File, Open, Open from my computer, and select the file, followed by the Open button. The other option is to open your data panel, open the desired project location, and create or choose an optional folder. You'll then be able to select Upload, followed by selecting the file or dragging and dropping it onto the modal. Remember that Fusion 360 uses cloud translation or Autodesk servers to interpret the imported data. This may take a minute or two, though it's usually less than 30 seconds. Once the translation process is complete, you'll receive a notification in the toolbar. We can then open the imported geometry. Remember, when you import files that are not native Fusion 360 files, you'll be placed in direct modeling mode. Direct modeling means design history is not captured and the parametric timeline is turned off. After importing geometry, you'll first want to take a look at how many bodies were imported. Imported files may include additional bodies that you do not need. For example, the first body does not contain any data, so I'll go ahead and delete it. The next consideration would be whether or not you need to place the bodies in different components. This is most helpful when you have many different bodies or parts. I'll create a new component, followed by dragging and dropping the body on top of the component in the Fusion 360 browser. Let's reorient the body, and then we'll look at how to find features used with the source file. You'll see that this model appears to have been created with a different modeling orientation. I'll right-click on the body in the browser, select the Move command, and before doing anything, we'll want to set our pivot point. This is the point at which the model will move or rotate. I'll choose the bottom center of the device. Then, be sure to select the green check mark to set the pivot point. We can then rotate the model 90 degrees, ensuring it's sitting in the same orientation as our view cube. The model is now centered to the origin point of the component. Remember, you can always use the point-to-point move command to snap bodies to the origin point. Let's click OK to confirm the move. You can save time with imported models by using the Find Features option. You'll find it in the Create dropdown, or by right-clicking on the body, followed by Find Features. In the dialog, you're able to choose which feature types to include. Generally, leaving this set to the default of Select All will be most helpful. Note that our body is already selected because we activated the feature from the body in the browser. However, you can always deselect or select additional 3D bodies. Once we click OK, Fusion 360 will attempt to find the solid modeling features that were used to create this model. All features found will then be placed in the browser. Remember, they're not placed in the timeline below as we're in direct modeling mode. This list can get very long, which is why I recommend creating a component before working on imported geometry. Notice how selecting the features in the browser will highlight the features in the canvas or the model itself. To quickly clean up files, you may want to delete a number of features that are not necessary. Double-clicking on some features, such as Fillet, will allow you to edit the feature. However, this does not work with all the features generated from the Find Feature command. It's important to note that this workflow only works with solid BREP files. If you're importing an STL or OBJ mesh file, then you'll want to check out my video on converting a mesh file to a solid. As you can imagine, Find Features can save a lot of time if you simply need to adjust a few things while working with imported models. Let's now take a look at how to reference this imported geometry to create a model around it. I'd like to use this approach to build a stand for my Google Home. Before that, I'd like to point out the line running down the middle of the device. This is a contour line displayed because of the default visual style setting. If we head down to the visual style settings and switch it to shaded, you'll notice the line disappears. Keep this in mind while working with imported geometry. Imported geometry can have irregular faces or edges, so it's a good idea to double check that it is in fact a visual style and not corrupt geometry. I like to copy and paste the component of the imported file to ensure that I have a backup before conducting any work. Remember to use the Paste New option, which will ensure the component is not linked to the original. Notice how the copied component also includes the found features in the browser. Before starting on the stand, I'd like to turn the parametric timeline back on so all future actions are parametric. Right-click on the root or top-level component, followed by Capture Design History. At this point, you're ready to utilize Fusion 360's full feature set, modeling in a parametric manner. However, you will see that a base feature has been placed at the beginning of the timeline. Base features serve as a container for any direct modeling in the file. At any time, we can double-click on the base feature to re-enter direct modeling mode. That allows you to continue to make changes in direct modeling mode without losing your parametric timeline when you leave the direct modeling mode. To create the stand, we can reference the existing Google Home geometry. Generally, this is best achieved using a surface approach, as surfaces allow us to focus on the geometry without worrying about the thickness until the end. I'll switch to the Surface tab in the toolbar, and I'll find the Offset command. This feature is different from the solid modeling offset, as it allows us to create a new surface body that is offset from the existing geometry. Contrary, the solid modeling offset will simply alter the existing 3D body. Let's define an offset of 0.5 millimeters and click OK. Hiding the solid body will show the result of our new surface body. It looks like the power port was offset as well, so we can go ahead and select and delete those faces. We can now use this surface as the foundation of the holder design. I want the shape to encompass or cradle the Google Home, so I'll use the Extend command from the Modify dropdown of the Surface tab. With the edge selected, we can go ahead and drag this up an additional 7 or 8 millimeters. Because our type is set to natural, the surface will extend or continue with the same shape. This can also be switched to perpendicular or tangent when needed. To close off the bottom, we'll need to do the same on the lower end. This extend operation will only be 1 or 2 millimeters, ensuring that we're past the bottom surface. We can then use the patch command to close the bottom surface. Now that we have the basic cradle complete, we can decide whether to continue with surface modeling or to use the thicken command to convert this to a solid body. That would allow us to finish the design with the solid modeling tools. Remember to stitch your surface bodies together before you activate the thicken command. This will ensure the surface thickens as one uniform body. At this point, you may also decide to import additional geometry. As an example, I've imported a Bulbasaur model and combined the cradle to hold the Google Home Mini. I've placed the model on Thangs.com so you can download it for free. Shout out to Thangs.com for sponsoring this video and another 3D modeling challenge. You can win a 3D Space Mouse wireless or a number of Amazon gift cards. This month's 3D modeling challenge is to make an accessory or holder for a smart device, such as a Google Home or Amazon Alexa. Head to productdesignonline.com/challenge to see all the prizes, rules, and submission deadline. Thangs.com is a growing 3D model community with over 1.5 million models available to search, store, and collaborate with. Even better, you can search models by related geometry. To summarize this lesson, remember the Find Features command is helpful when working with imported models. You'll want to consider whether or not you would like to work in a parametric modeling mode or direct modeling mode. Using the surface features will often provide more flexibility when working around existing or imported geometry. Last but not least, special thanks to all the new patrons and those who have supported the channel via my Buy Me a Coffee page. Be sure to check out the new Product Design Online Academy, where you can gain access to my Fusion 360 training courses, members-only community spaces, and more.